Task 5 is all about CSG tallies, Constructive Solid Geometry tallies. This is where it all comes together for the first time in my favourite tally, the tritium breeding ratio tally. So here we have a reactor with a nice plasma, and we zoom in and we can see there's some tritium there and some deuterium, and they are going to collide together and make some helium-5 for a very brief amount of time before it falls apart and throws out a helium and a neutron. And that happens in the plasma. And if we were to surround the thing with breeding blankets, we can see what would happen inside the breeding blankets. The neutrons all come out isotropically, and some neutrons go straight through. That's no good. Some neutrons interact with lithium-6 and they make tritium and they make helium. So that's great for our tritium breeding ratio. Some interact with lithium-7 and they produce tritium, helium and a neutron. So in some ways that's even better, because this neutron can go on and do further interactions to produce more tritium. Another option, if there's beryllium multiplier or another sort of multiplier in there like lead, the neutron can come along and it can split the product, and in this case it makes two neutrons as well. So these neutrons can go on as well and do other useful interactions. So I should mention that it's not a never-ending chain, and the neutrons produced in the lithium-7 and this neutron multiplier reaction don't normally have enough energy to go and do this again. So there are the three important reactions in the breeder blanket to make the tritium breeding ratio. So you can change the fraction of materials within inside the blanket, and that's what this task is going to do. We're going to change the fraction of lithium-7 to lithium-6 and see how that impacts the overall breeding ratio. You might remember from task 1 that lithium-7 requires high energy neutrons and lithium-6 is more likely at low energies. So in the task you will do a parameter study where you vary the lithium-6 enrichment and you observe the tritium breeding ratio change. I'm just going to launch the Docker container, and I'm going to go down to task 5. So this is the first task where we will put everything we've learned into one place. We use the material making that we learned in task 2. Here's some more material making. We use the geometry making that we learned in the task 3. And we use the source that we learned in task 4. That's combined with simulation settings and then the tallies, which I suppose that's a new part for this task. And once you have all of those things together, you can combine them into a model, geometry, materials, settings, tallies, and you can run that model. It produces an output file, and you can read that output file in. You can even convert it into a pandas data frame, and then you can extract your results and your standard deviation, and you can plot them. Or in this case, just print them to the screen. The second part of the task, you plot them. Good luck with task 5. Thanks for listening.